Hello, here we are again for another video. This is performance task number 7 and my name is Carl Joseph Rizal, a BS ECE 3A student. So here is we're gonna solve the Hamming code. So an error in the Hamming code. So here we have our initials to get the examples first. Let's change our pointer. So we have our K, our J, our S, and RR. So KSR. So convert your initial binary using 8-bit ASII code. So we have here our values. So we can see here where we get our values in our initial. So we have here our K, and we have here our S, and we have here our R. Okay. So here combine all letters, KSR. So this is the 24-bit number. So split in the middle to get the two 12-bit binary numbers. So here, as we can see. So the two results will be your two assigned 12-bit codes. So checking for error of Hamming code. So code received here is the first one in that we split on our 24-bit. So we have 0100, 1011, and 0101. This is the equivalent hexadecimal value. So we have the D received and the P received. So how we get first our P received. So we get our P received here, get this one. We get also this one, and we get these two. So we have here 1001. So in the D receive is the remaining code here will be your D receive. So 0100 011 and 1. So this is the your D receive and P receive now. So here we have our Hamming code table. X is equals to 1 and blank space is equals to 0. So as we can see here, this is what we talked about last time in the table. X is 1 and the blank space is 0. So we need to solve here. It will become to 0, 0, so there will be no error in our Hamming code. So this is the formula. So as we can see now, this is our first example. 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1. So this is our values in D received and P received. So we just substitute the values here. So we just highlight those values with 1 times 1. So 1 is equal to 1. We have here 1. We have here 1 1 1 1 and 1 1. So we in another we have 1. We have 1 1 here and another here. We already highlighted it, but we need I need to just as you can see, so that you can see, I mean. So we have here 1 1 and 1 1. So another is 1 1 and 1 1. So it will be equal to 1 plus 1 plus 1 plus 1 is equals to 4, and 1 plus 1 plus 1 is equals to 3, and 1 plus 1 is equals to 2, and 1 plus 1 is equals to 2. So convert even is equals to 0 and odd is equals to 1. So we can identify where is the error on our Hamming code. So 0, 1, 0, 0. So where is that? In our number 2 here, as you can see. 0, 1, 0, 0. So how we check our error? So therefore error in bit number 2. So here we change our code here from 0 to, this is 0, right? So we will change it to 1, so that the equivalent will become to 0, 0. So let's substitute again by changing it. So we have here, we substitute here 1, 1, 1, 1. So 4, so we have here 1, 2, 3, and 4. So it's equals to 4. So even is equals to, if we convert even is equals to 0. So again, we have here 1, another 1, plus 1 again, and plus 1. So it's 4 now, so it's equals to 4. So we convert it to 0. Then another is 2 and 2. Here 2 equivalent to 0 because it is even. And we have here where 2 1 plus 1 so equals to 2. So we have here a 0 0 now. So therefore there is no error. So next is our example number 2. We have our code received 0011 01010. This is the hexadecimal value. It is the same where how we get our P receive. We just get this one on this one and this two. So our P receive is 0010 and the remaining will be our D receive. So consecutively, this is our values in D and P. So the same process that we used in example number 1. So here are P values, our D and P values, we substitute. So um, we have here 1 plus 1 plus 1 is equals to 3. We have here 1 plus 1 plus 1, 3. 1 plus 1, 2, and 1 plus 1, 2. So the values, let's convert it. So even is equals to 0 and odd is equals to 1. So the value isn't 0, 0, 0, 0. So it means that there is an error. So how do we find the error? So P1, P2, P3, P4 is 1100. So we find the error in bit number 3. So we have here, as we can see, 1100. So next, how we change it so that there will be no errors. So there's a error in bit number 3. So we change it. So we change the value of our bit number 3 here because it is 0, right? So it will change to 1. So now substitute again. We have here 1 plus, we have here 1 plus 1 plus 1 plus 1 is equal to 4. So it is even, so it is converted to 0. So another is 1 plus 1 plus 1 plus 1 is equals to 4. So convert to 0. Here is 1 plus 1, 1 plus 1, so 2. So we have here 0 again because it is even, and 1 plus 1 is 2. So it equals to 0. So therefore there is no error. So assume the two assigned 12-bit codes are here. We have here our examples. So code received, D received, P received error is in bit number 2. So we change it. It's different now from here to here. So our descent is 0100 and the pcent is 1011 now. So the code number 2 we have here, the received or pre-received errors in the bit number 3. So we change it from 0, change it to 1 so that there will no error. So descent and pcent. So that would be all for today's video. God bless. Thank you for watching.